Right, good morning and welcome. Good afternoon, wherever you might be joining us from all over the world. I'm coming to you live from America. It's currently 6 a.m. email address, so if you can hopefully hear me, just give a confirmation and we'll get started with AI tactical skills for drone hacking and defense. All right, I'm assuming that you can all see me. I've got a backup machine running, so I've been prepared and ready. Let's get started with this afternoon's drone hacking and defense. I'm going to skip over the background about myself because we've lost a little bit of time. Once again, I do apologize. We will make sure we solve these things. Obviously, with the geopolitical technology right now, when you've got to log on to different regions, it's sometimes obviously challenging. But anyway, let's get started. We're going to be talking about how you can build your skills in drone hacking and defense. This was a little bit of news from Ukraine. Joining a NATO counter drone exercise for the first time. So this was run in September 2024. There were 450 participants from NATO allies, 3 partner countries that gathered in the Netherlands to really test the ability of commercially available counter drone systems, because we're going to be dealing with a lot more drones in the field doing all sorts of things, delivering packages, emergency medical rescue, police, military. And so here's a quick demonstration of what happens when a drone is hacked while in flight. Now it's a little noisy, and this was in a European country. You're going to see there's going to be a laser on the ground that starts tracking the drone. So we fly in reconnaissance, and you'll see how close we get to the statue there. There was some sensor, and that automatically started a tracking system on the ground. And you're going to see what happens when the green laser locks on to the drone gimbal. It's going to actually disable the gimbal, so you'll actually see it actually drop. We needed to leave that area very quickly before it locked on to our drone. So there you can see in the bottom left, there's the green laser light. And you'll see in a second that's going to affect the drone gimbal where the camera's mounted on. So if this was a drone that was run by the police, we would have had a problem. And so this is where we can see a lot of military organizations such as NATO. They're exploring new drone technology as Pandora's box, opening the Russia war against Ukraine, of course, because they're constantly in the sky. They monitor the territory along the front lines. They give so many problems with a $2,000 drone targeting 1 to 4 million euro vehicles like tanks and so forth. So they're really using them for intelligence, surveillance, and reconnaissance. We can see if these types of drones are perhaps used to attack some civil objects in Europe, then it's going to be very difficult, extremely difficult to defend. And this was from Ukraine's Innovation Center. So these guys are very aware of drone urban warfare. And of course, the civilization is not ready, which is why we're coming to you. I come from a law enforcement police background. I was in a special unit. I've had many near-death experiences. So I can tell you right now, when you have these types of devices that can fly very high without very much sound and sight, these are potentially lethal situations that we need to be prepared for. Now, we can use drones for good and evil purposes. This is going to be an example of looking to show you how it can actually be used to save somebody's life. This was a little girl that was lost in a huge forest, and it would have taken 300 people and many hours to try and find her had there not have been somebody with drone technology.
Louisiana officials say the young girl Peyton vanished after sleepwalking into the woods.
At that time, we didn't know what had happened. We, had to think the worst. Maybe we didn't know, if she had been abducted.
Nearly a dozen law enforcement agencies and hundreds of volunteers were searching for the child when Arkansas-based drone operator Josh Clover decided to drive up 40 miles to help.
I get calls all the time, and this one, the lost girl in the woods. We were just trying to do the right thing.
Clover says officials helped him set up his gear, including a generator and a large flat-screen TV, before launching his drone above the thick woods.
That thermal drone can scan about 160 acres an hour. Walking around the woods, just volunteers. There's no telling how long it would have taken.
After about 20 minutes of searching, officials say they found the girl asleep and curled up in the fetal position on the ground.
It's just amazing that, other than some mosquito bites, that she was unharmed. Just in perfect condition.
Peyton was 300 yards from where a trail camera had seen her that morning. Sheriff Jason Parker says Josh and his team made all the difference in the search for Peyton.
If Josh and his team was not been able to locate her with that drone, our next step was to line up shoulder to shoulder with flashlights with 200 to 300 volunteers, and we were going to walk the woods.
Well, there's a lot of messages coming in online, and I tried to reply to a lot of them. I'm sure I missed some folks, but we appreciate all the words.
Peyton's family telling authorities she does have a history of sleepwalking, but has never left the house. But thanks in part to a good Samaritan and a drone, she's back safe and sound.
We couldn't be more blessed on how this thing ended.
Oh, so this is for good purposes. This is not going to be so good now.
Super proud. It allows you to separate the bad guys from the good. It's a big deal. But we have something much bigger.
Right, so when I was in the police, we didn't have these things. This is really going to make law enforcement so much more effective. Less the explosive though, so maybe using a dart that would put somebody to sleep and not kill them. But this is the part with AI.
Can react 100 times faster than a human. The stochastic motion is an anti-sniper feature. Just like any mobile device these days, it has cameras and sensors, and just like your phones and social media apps, it does facial recognition. Inside here is 3 grams of shaped explosive. This is how it works.
All right, so I think that's enough for our lunchtime warm-up. That was a very, very small drone using artificial intelligence. I'm going to be showing you one of our first-person view drones today. This is a much smaller form factor for average sizes, but this is also used for racing. So we can use various different types of payloads, and I'll be covering a little bit more details and showing you some demonstrations of that pretty cool little beta FPV drone. So when we look at drones, we really need to understand the different types of sensors. You have your flight controllers, you got your radio frequency, you got your communication systems with various different types of telemetry type of chips. So you can see in the picture there, that's actually a DJI teledrone that's designed to actually learn programming and automation and swarm flying with, an open source drone that's pretty powerful. Now, you can also use various different types of other form factors. When we look at first-person view, this is where you're going to be flying your drone with a headset, right? So you're going to actually be using first-person view, and you're going to have 3 main components that could be hacked. You got your remote control, right? That controls the drone. You got your first-person view headset. This is a pretty big one. We also use much smaller ones, but this is just showing you how they come in the kit. And then right now, I've got the drone ready to be plugged into the computer when we get into showing you some of the actual software that you configure. Now, the drone you're seeing in front of you is the Speedy Bee Master. It's a really fast racing FPV. And you'll see on the top right-hand side that adapter allows you to actually wirelessly flash your firmware, configure all of the advanced settings, like look at your black box flight data, where you can actually analyze that. You can do your wireless electronic speed controller flashing. It's a charger. It's also a LiPo battery checker, where you want to check the voltage of your battery. And it's got an application compatible with Apple and Android. So you can actually see the specifications broken down for you. These are the types of systems that are typically going to be used by military, law enforcement, emergency, medical, and rescue. Obviously, doing different things. You might have a bigger drone, as you're about to see with some of the other demo videos we have, where they come in all shapes and sizes. Quadcopters with 4 motors. You've got hexacopters with 6, octocopters with 8, and you can also have them both on top and below to obviously bring a lot more power. So these are pretty standard, straightforward drones. When you look at trying to hack into drones, you're going to need some technology. A drone that you want to try and hack into. Now, there's various different types of drones. When we look at the commercially off-the-shelf drones, those are the ones that we're most concerned with, because whilst this might not have a flight distance of many kilometers, this could carry a small amount of explosives. As you could see when we looked at that video a few minutes ago, that was a very small drone programmed with artificial intelligence and 3 grams of shaped explosives. So this is just typically going to be used for reconnaissance. You need obviously some kind of a laptop, desktop, your phone or tablet for some of the applications that will be used to control these drones as well. And then to intercept the radio communications, you need to use a software-defined radio. You can use the Hack RF with a Porter Pack. ETIS is our preferred platform, as it's more military grade, but you can use the Pluto and Lime SDR as well. So there's a large variation of software-defined radios you can use. Now let's take a look at a much larger drone. These are drones that I've been building for the last 10 years and specializing in AI. We will normally add our AI computer. Right now, we're currently testing the new Raspberry Pi 5. As you can see, it's actually got the AI chip built in. So we're constantly engineering with all the latest and the greatest of technology, using all sorts of different types of sensors. We even use Raspberry Pi Zeros for some of our signal detection, as we've been learning a lot about the offensive attacks in Ukraine and Russia using all sorts of drone technology. So take a look at this next video. This is showing you a very big hexacopter that we built 10 years ago. So you're going to see how fast things have changed. When we're looking at our ground control station, our software, we now have it fully kitted out into a Pelican case. I have it with me, but it's not something I can just easily pick up and show you because it's in a very big Pelican case. So you can see where we were 10 years ago to where we are now. Looking at the video. So as you can see, we just got to take a quick test flight. So this is a test flight. Everything's working, the screen display. So that's looking at the video feed, and the ground controller software can be run on a tablet or a laptop. And this is a pretty big lift. So I'm just going to test to see if everything is running smoothly. One of the propellers had a cable tie that was catching. So we had to just make sure we checked before we initialized the full in-flight. We check in, adjusting. And this is, as you can see, the size of this drone. This is a very big lift drone. It has a custom rail system where you can load different types of modules on there. LiDAR, sonar, radar, lasers, acoustics, and improvised explosives. Obviously, whatever your preference is, what your mission might be. So you're going to see this is a very, very smooth flight. You'll see as it's about to take off, but very, very powerful with a lot of lift. So when we train people to use drones, we take somebody from a complete novice background with no previous skills at all to use drone technologies. For level 1, you're going to be looking at the fundamentals of how drones function. You're going to be troubleshooting drones. So we use an array of different types of drones to actually troubleshoot. One would have a problem with software. Another one would have a misconfiguration on the electronic speed controllers. So we really help people learn to defend, build, troubleshoot. And once you've gone through level 1, you've covered the foundational elements of how you use drones in the real world for good and potential bad purposes. You know, when you look at guns, guns can be used for good purposes. You might be going hunting where you live on a farm. It doesn't need to say that a gun has to kill people. It's the people that choose and make those choices. So we'll be building, modifying, and designing robotic vehicles with focus on drones, UAV, UAS, AI, machine learning, swarming, and of course we have very many different levels. I personally train a lot of the US military special forces, where they train to do first-person view. They train to weld and solder and fix, so all sorts of sizes and shapes of drones. And what we have to consider, you may have remembered the case a few weeks ago with the exploding pages. So these batteries are highly combustible, but they're not going to blow up. They're just going to burn normally. So we have propellers that are moving very fast, that are very dangerous. And you also have very highly combustible battery substances when you're using hydrogen, gasoline. It's very dense energy. So we typically use LiPo batteries within our commercial off-the-shelf drones. We've seen a huge movement in the field of tiny microchips. So millimeter wave radar technology has been invented and is now being used in a proof of concept device. It has a frequency range of 30 to 300 gigahertz. It's located between microwaves and infrared. And these, as you can see, are very, very small. That's like needle nose pliers holding that tiny millimeter radar. So we need to be aware when we want to fly drones, you need to be aware of your local laws in your country. I've lived in the Czech Republic for 10 years. I've lived all over the world. Currently, I'm based out in the United States. We have a company out in California, and one of our areas of specialization is drone security. And since the actual uptake of drone technology in all sorts of uses, delivering packages, emergency medical services, police, military, we really want to help civilization be better prepared to defend and also manage drones in the field. So whatever your job might be, you need to ensure that you are able to fly in a specific locality where you've got applications that you can check if you are legally allowed to fly. Up in front of you, you can see on the very left-hand side, you have your controlled airspace. So that's going to be a no-fly zone. However, we're also able to show you how to actually unlock the fly zone so you can actually remove any restrictions that the drone manufacturers impose on the drones. So these no-fly zones are obviously circumvented by criminals using the drones to maybe deliver drugs to prison cells. We've seen big drones fly over prison buildings and obviously drop packages into the actual prison grounds. So on the right-hand side, you can see in the middle, there's caution. So you can fly, but you're very, very close to an airfield as an example. And then on the right-hand side, where you have clear airspace, where you're obviously able to actually fly. So we need to be aware of our surroundings and the location we intend to fly our commercial off-the-shelf drones. We've seen a lot of education being offered to all sorts of governmental and military organizations. As I mentioned before, since I come from a police background, we didn't have this type of technology when I was in law enforcement. But I worked very closely with a lot of military and governmental organizations globally, a lot within the European Union, as well as out in the United States. So this is Interpol doing a drone incident response, building a framework, and this is to be able to obviously respond to incidences where you have to collect the digital forensic information. So Interpol further carried out full-scale drone countermeasure exercises. And this was done in order to be able to see how effective we are to be able to defend our airspaces when there might be some kind of a terrorist attack using drone technology. So when we piloting, we really need to be aware of birds that you might not realize. Birds don't like drones. I was out in many different European regions like Italy, just flying reconnaissance near military bases as an example. And I tell you what, some of the actual big seagulls literally dive bombed some of my drones, because what you got to realize is these drones are using a lot of radio frequency. So they have a big electromagnetic field. Birds don't like that because it's interfering with their GPS internal, natural system. So even when you're flying within the rules, it may not be a good idea based upon the surroundings. If you're near a beach or an ocean where there's a lot of different types of bird species, they're going to attempt to try and dive bomb your drone because they don't want you to be interfering in their flight GPS system. So this is a great example of fly by AI. This is what we use in high special operations in military use. It's fully automated. It's not with a drone pilot. This is flying itself using AI. So you can see that's constantly feeding back information to a map. So it can be used to go into a specific room and find and mark specific threats. So it can actually highlight areas of potential risk for the people that might need to walk into that building. Maybe they're doing search and rescue. But this drone is all flying itself. It's all flying itself based upon artificial intelligence and a whole lot of sensors. So it's autonomously returning to the actual launch site. And this is without anybody having to actually fly that manually. So it's all flown with artificial intelligence. Now, for those of you that are new to drone technologies, this was a TED Talk presentation done years and years ago, but it shows the astounding athletic power of quadcopters, how they can be used to do multiple things where you actually combine more than one drone to work cooperatively. And so these are just some of the things that we can do when learning to program drones. As an example, we're going to teach you how to use Python as an example to actually build automation within your UAV, your drone automated types of programs. So this is an example of the DJI Tello. It's actually a very small drone that was developed to be used for educational purposes, to practice being able to program the drone, where it's actually got 14 core processor for its computer vision system, where you can actually automate and add your AI to that. So these are no longer manufactured. So we're using other types of drones for our educational programs, which basically people have options. This is from our level 2, level 3 kind of courses. We cover some of the digital forensics as well for drones. So we've been doing drone technology, as I mentioned, for over 10 years. And we've been delivering these programs dedicatedly to a lot of governmental and military organizations. But since this is becoming a huge civilian problem, we are really bringing our technology, our training, our education to the actual industry, the civilian world. This is why we partnered with GOPAS to ensure we can start helping the Czech people, at least the Slovak people, and all the surrounding areas within the European Union, because they love coming to Prague and Slovakia and the beautiful, Eastern European countries. So let's get into some of the actual specifics of how drones really function. When we look at memory, we need to understand there's all types of memory that's going to be used. There's memory within the electronic speed controllers that control the actual motors. There's memory to maybe record your videos. You're going to be storing all sorts of different types of data for your camera feed, for your flight data, for black box. And this is all data that can be interpreted to obviously troubleshoot and fix some of the drone problems. So you might see the picture over there from 1912, which was an illustration of a very old cell battery. Well, as we mentioned before, typically at home, you use your alkaline or non-rechargeable NiCad rechargeable battery. So we're using alkaline or NiCad batteries typically, right? But when we look at drone technology, we're using LiPo batteries. So lithium batteries actually have a lot more higher capacity with low weight, so using most current phones. But modern remote control batteries can discharge 100 plus amps. So they get very hot. As you actually charge the cells, they expand and decrease, which is why LiPo batteries are very, very, very volatile. Now, when we look at the motors, we'll be discussing the different types of motors that you get within drones. Some of the cheaper drones will actually use a brushed motor, and some of the actual more higher end devices will use a brushless motor, because the brushless motor allows for very fine-tuned rotational control with minimal parts. However, this is why they need a mini computer called an electronic speed controller to be able to fine-tune those brushless motors. Now, having a look at the screen, you can see on the left-hand side, you have a very simplified view of a brushed DC or direct current motors. Those are used to, they use small brushes to apply the voltage across a dormant electromagnetic, so your magnetic energy produced by electricity, which can be very easily switched on and switched off. So you can actually see the north and the south poles there, versus the actual more powerful brushless DC motors, which, as I mentioned, they normally have 3 or multiple electromagnetics instead of just one. So this is why you have an electronic speed controller, because it allows you to use much more precision timing to control the rotational, what we call your PID values. We won't get too deep into what PID stands for, but when you're looking to tune those motors, the brushless motors are high-end. This is showing you the brushed motor that you would use in those cheap DJI Telo drones. They're about 150 euros when they were still being manufactured. And you need to be aware that they have a typical lifespan of about 40 hours. So the wear and tear, obviously, of these brushed motors is what makes them, pretty cheap. Whilst when we look at a high-end brushless motor, this is an image from DJI. You can see the array of miniature little magnets wrapped around with the copper coil wire, generating a pretty big field. So brushless motors take the aircraft into the sky. They need to keep cameras level, keep flight smooth. It has its center and as an assembly of silicone steel sheets and windings, which we call those coils. And the actual coil doesn't spin. That's called the stator. And the actual surrounding stator is an assembly called the rotor, which basically contains a magnetic yoke, as well as a circle of permanent little magnets, as you can see. So going back to that previous diagram there, you can see on the right-hand side, the brushless DC motor. This is just showing you a very small form factor. Now, even on this very small drone that I have over here, you might not be able to see it, but at the back, these are all brushless motors, pretty high end, yet they don't use high cell batteries since this is a much smaller form factor. So we need to understand in a single phase motor, when the electricity is actually fed into the stator, a magnetic field that attracts and repels, it basically pushes and pulls the magnets in the rotor, causing it to spin through your 180 degrees. So this is effectively the force that powers the motors to create stable flight. Now, the next very important component is your flight controller. A lot of these different types of flight controllers and IoT, biomedical chips, they all have the same thing in common. They're using an ST microelectronics STM32 family chipset, which is essentially, when we look at flight controllers, it's responsible for collecting all of the data issuing the very fine motor controls to the electronic speed controllers. And then we use specific PID values and settings. Those are basically algorithms that are used to reduce the difference between the actual and requested positions. So when we look at trying to create stable, smooth flight, we want to look at our actual loop times, because the loop times are the enemy of smooth flight. If you don't have your PID values and your loop times tuned very well, you're going to have a pretty unstable shaking and jittering drone. So take a look at this next little animation. This is where we're going to show you all the different things that we can use on drones to teach people how to become drone efficient at managing drones, at troubleshooting drones, whether it be for all sorts of different purposes. So this is the Cetus Pro, and it comes in a really small little kit that takes you from 0 to hero. You can see it's a very small single cell LiPo battery with 3 different flight modes. Even young kids can fly these drones, as well as adults with altitude hold. You can see it's very stable. Even when you try and push it, it has horizontal lock. So it is very, very powerful. It has sport mode, which gives it a lot of speed and precision to fly in and around all sorts of difficult terrain. So unlimited freestyle flying, you can do flips. This is a drone course, as you can see. So this is where we fly with first-person view goggles. The turtle mode allows it to flip over if it goes and crashes. It has emergency landing with a lot of safety features. Obviously, the propellers are encased in a cover that's obviously going to make it pretty safe for people to use. And so now I'm going to take you through plugging this in, and we're going to look at the actual software called Beta FPV in this case. So you will actually tell right now I've got a little connector that connects into the actual bottom of the drone main board, and I can now plug this into my desktop, and we can show you some of the software. So now that it's plugged in, you'll see all the lights start flashing. Let's bring up the software. And you can see it's detected on COM port 6. So I'm just going to connect. And this is the main software where you can now see we have the ability to go and configure and set up the drone. This is a modified version of Beta Flight, which is a very well-known open source drone controller program. It gives you all sorts of abilities, very similar to what you're seeing here. You can tell when I'm picking up the drone now and moving that around, you can see it's actually showing you based upon the actual accelerometer, magnetometer, all built into this actual drone. So you would go through your initial setup to calibrate your accelerometer, your magnetometer. Then you have the ability to go and set up your receiver. So this is where you obviously want to control your different values to ensure they're configured for smooth flight. You can select different types of receivers based upon which model you may have purchased. And then when it comes to the motors, you have the ability to obviously do your motor test. As you can see here, I'm not going to do the motor test right now. Normally when you do this, you want to make sure you removed all of the actual propellers from the actual drone. And as I was mentioning, your PID tuning, this is where you can actually go ahead and configure what we call your proportional, integral, and derivative. So these are your main PID values for your roll, your pitch, your yaw. And this is, again, just very limited software where I will be showing you an example of some other software shortly. So you have the ability to monitor and configure all of your actual sensors, your gyroscope, your accelerometer, your magnetometer, your barometer, and then you've got certain other settings there that you can see. We won't get into too much of the deep technical spec here, as we still have a lot we want to talk about. So this is how we'll go through and actually set up our firmware. very often we can actually flash the firmware. So if I disconnect, this will allow me to go into the firmware flasher, and I can actually flash the flight controller. I can also flash the radio transmitter. And so this is, again, some of the fundamentals of managing drones of different shapes and sizes. So I'm going to unplug that. And so that brings us to speaking a little bit more about our flight controllers. So the flight controller is essentially the heart of your actual drone, right? It's the heart of your robots. It's the brain of the aircrafts. It's essentially a very small computer that nearly all flight controllers have very similar basic sensors, as we're looking at the sensors a minute ago. So a lot of flight controllers will have those different sensors, such as your gyroscopes, your accelerometers, because those are some of the very basic sensors that are needed for flight. Your barometers for your barometric pressure sensors, and then your magnetometer for your compass. This is showing you a table of typical popular first-person view racing flight controllers. So these are pretty small form factor normally. And you can see ranging from the F4 being very popular for racing drones, as well as the F7 processors. And this is where we want to take you into a quick deep dive of an example. This was a very cheap 15, 20 euro flight controller. That's just for the actual computer. The rest of the components all cost a lot more money, but the main flight controller there you've seen in the middle of the screen with all the peripherals connecting to it. So you have a GPS, you have a telemetry radio transmitter receiver. So you have your telemetry, your power voltage of your battery, so monitoring your battery voltages when you're in flight. You have your electronic speed controllers, your power distribution board. And very often when we use artificial intelligence, like if we want to add a Raspberry Pi with our AI technology for, let's say, the computer vision, then you're going to need to use something like a UBEC or a battery elimination circuit. And so what that does is it will take, let's say you're using a 2S cell LiPo battery, it will reduce that 7.4 volts down to the 5 volts, which would be needed to power that Raspberry Pi. So in essence, you can see this is a very simple but straightforward schematic of a very popular and cheap flight controller that you can use when you're just getting started in the drone world. Whilst some of the other drone flight controls we showed you, like the Pixelhawk, those are pretty expensive because they give you all sorts of capabilities by adding your flight companion computers for artificial intelligence. Now, breaking the actual CC3D down a bit further, you can see it has the STM32 chipset. It's an ARM Cortex M4 running at 210 MIPS. So these are not high-end computer systems. This is a pretty cheap flight controller, as we spoke about, but it's still very, very capable of allowing you to integrate all sorts of additional telemetry. So you've got your I2C, you've got your SPI, your UART, your 2x by CAN buses, all allowing for collaboration within the actual main flight controller. Now you can see the ports that we have. Generally, we have pulse width modulation or PPM receivers, where you're using either multiple wires for your radio telemetry, or you're using single wires that can feed multiple instructions through those single wires. So the next little bit of software I'm going to show you is the original software that you would use to configure your CC3D drone. This is Libra, and let me see if I have that running. Give me 1 second, I'm going to go and find that software. So this is also a ground control station, which allows you to set up automated flight paths and all sorts of things. Although this is pretty old now, This is again indicative of how we can actually also set up our vehicles. So you could go through a vehicle setup wizard, which we won't go through the vehicle setup wizard. We want to take you into the actual main system. So again, this is where you can actually see your initial welcome screen, and then you can dive into your flight data. This is known as your ground control station. So it will obviously allow you to track your drone when you're using GPSs as an example. Now, I haven't actually plugged in a drone, so it's not going to show you some of the other settings. As you can see, this is just the initial software interface. We have the ability to also go into the configuration, and this is where it gets really interesting. So you can see we can dive deeper into each of the different elements. So the hardware first, which when you plug in a flight controller, you would obviously identify the hardware. Then onto the vehicle, where you can actually configure the actual airframe type. You've got different form factors. Here you can see this is the Quad X as it's in the actual X configuration. And you can see how each of your different motors are turning in a specific direction. And so when you build in drones, you can very often nowadays through software change the direction of the motors. Whilst when we were first building some of these drones some time ago, we would actually have to remove one wire and solder it to a different port so that it obviously spun in the right direction. So you have the ability to set up your software for multi-rotor, like multi-rotor quadcopters as an example, or fixed wing helicopters, ground vehicles as an example. So all using the same types of ground control station software. And then onto the actual input, your remote control, where you can actually set up all of your different functions, your throttle, your roll, your pitch, your yaw, your different flight modes. And then if you've got any other types of telemetry, like LiDAR, like sonar, like radar, all sorts of different modules that you can actually add on and control. And then you also set up your different flight mode switches. So you can actually set up different switches to have various different types of pre-configured flight parameters. So maybe you want to fly in sport mode where you want to be very fast. Maybe you want to fly in cinematographic mode where you want it to be very stable and smooth flight. You also have your flight safe settings. So when things go wrong, this is why you want to make sure you also have telemetry feeding back to your ground control station. So you're always aware of how much voltage you have left in your batteries. So giving you how much time you still have in the air. And then when you get ready for flight, you need to set up your arming settings. So making sure you've got a specific key sequence in order to actually arm your motors ready for flight. Arming them means they start spinning slowly in certain situations. You could control that if you like, but most of the time when you actually arm the drone, the motor starts spinning very slowly, getting ready for flight, very similar to like an airplane on the runway. So you also have the output, where again, you have the ability to configure various different parameters for your motors. Then you have your actual attitude, your different flight parameters to show you. I can't show you right now because I don't have a flight control plugged in. But you also then have your stabilization settings. So you can actually have various different types of configurations for flying in a moderate way. You can configure that to be more snappy, so much more responsive. And then insane is obviously right off the scale when you're going to be doing all sorts of different types of hardcore flight tricks and whatnot. So you've got different settings. You can use settings bank 1 for one set of parameters. Then you can set another set of parameters in your bank 2 and bank 3. And this is just showing you the very basic settings. When we go into advanced, you can get very, very, very specific. And so this is more from our level 2 type of training, where we go into much deeper elements, looking at the actual PID scaling. And then on to expert, where we obviously make very, very slight changes and obviously validate these changes by taking drone back out to the flight field to test obviously the configuration. or you might have an indoor flight space for you to fly. It all depends on the different drones. Some of them require GPS signal to actually be flown. So not all drones could be flown indoors unless you actually remove or configure some of those parameters through software. So you have the ability to also do some auto tuning, to control your gimbal. Your gimbal is normally where you have some kind of a device like a camera mounted on the gimbal, so it's very stable and smooth. You can see from one of the video demos I showed earlier on where it was actually targeting, it was being targeted by a green ground mounted laser. So that's, of course, we were very near to a military base, I believe, where there was governmental institutions where they obviously protect the airspace, and that's where that green ground station laser was obviously mounted. So that was actually in the field. And then we have the ability to go and set up our PID again for your specific transmitter. So not all of these settings are available on all sorts of flight controllers. It all depends on what modules you've actually added on there. But in essence, this is the main software that you can use, of course, to do a lot of your configuration. There's some more of your actual major system settings. You've got the ability to monitor, very similar to what you saw in the beta FPV software, and then also setting up your actual parameters for flight. And then the final part there is actually flashing your operating system on the flight controller known as your firmware. So that is a nice example of Libre Pilot, where you would use this software to set up those more cheaper type flight controllers. And then the other beta flight software, which is also what is most popular right now for first-person view. So we won't have enough time to go through beta flight today, though, but this is where you would use Speedy B as an example, where you can do Speedy B configuration from an Android or an Apple device, or you can actually use beta flight on a laptop, desktop computer. You can see the way you can actually interact with your flight controller. So connecting to your gyroscope, your accelerometer, your barometer, your GPS, your magnetometer, and then your receiver. So this is showing you all of the different types of peripherals, like your first-person view transmitter as well. And so that was really our content for today. I want to just thank you for sharing your time with us. It's been an honor and a privilege to deliver this to you folks. We are constantly evolving, so let us know if there's anything we can answer as far as questions are concerned. I'm not sure how much time we might have left, but you can find us on LinkedIn. We will be delivering some of the first drone programs in Slovakia in the near coming weeks. So please contact us for any specific information. And I'm going to go to my backup machine to see if we've got any questions that some of you folks would like answered.